Hey, the learning target for today is solving problems using proportions, and I'm including in this presentation writing and solving equations as well from word problems. I am hoping that by now you have learned to stop, pause, do the problems on your own, and then go back and double check after watching me that you got the right answer. So right now, stop, pause, and go through these two problems. What are the steps to solve this problem? This is a one level on your summative. What do you have to do to solve this problem? And the new topic, which I'm hoping you remember how to solve, and I'm trying to give you a hint right here, how to solve proportions. Okay, so this question right here, you have to be able to say the steps that you need out, like in writing. So not just show the steps, you have to use words. So to solve this problem, we see that here's my variable term. There's a 4 added to it, and it's being divided by 3. Because this is in the numerator, we have to get rid of this 3 first. So the first step to solving this is multiplying both sides by 3. It's divided, so we're going to use inverse operations to multiply to get rid of it. Properties of equality tells if you do it to one side, you have to do it to the other. And then after that, we will have x plus 4 equals 36. And then we have to use properties of equality to get rid of this plus 4. So inverse operations, it's plus 4, so we're going to subtract 4 on both sides to get x equals 32. 32. All right, and then solving. You need cross multiplication to solve proportions, and that's what we're going to be doing today, is cross multiplication to solve proportions. So x times 12 is 12x, and 2 times 72, well, 2 times 2 is 4, and 70 times 2 is 140, so we have 144. Then again, properties of equality and inverse operations, it's multiplied, so we're going to divide. If we do it on one side, we have to do it on the other, so x is 12. So what it's saying is 2/12 is the same thing as 12 over 72. All right, let's get to some vocabulary. In algebra, as you know, we use variables. So this here is read A is to B as C is to D. You use this proportional thinking sometimes in English as well. Puppies are to dogs as kittens are to cats. So that whole analogy. And so here we read it, A is to B as C is to D. A and D are called the extremes, and B and C are the means. So A, D are the extremes, B and C are the means. And basically what we know, if two ratios, so things that look like fractions, they're two ratios, are equal, their reciprocals are equal too. So that's one of the things we know. So 1/2 equals 2/4, therefore 2 over 1 equals 4 over 2. And that makes sense. The other thing we know about proportions is that the product, so if you multiply the extremes, so the product of the extremes, so if you multiply the extremes, it equals the product of the means. So if you multiply the extremes, it equals the multiplication of the means. In other words, cross multiplying. A times D equals B times C. And we can use this to solve proportions for a variable. So I usually show it like this. 4 times 15 is 60, and that's going to equal 3 times x. And then we can solve the equation. It's multiplied, so we have to divide. And then we can check by plugging it back in. So 4 is to 20 as 3 is to 15. And if it works, then it can be reduced. And we know 3/15 is 1/3, and 1/5. And 4/20 is 1/5. or we can multiply. This equals 60, and this equals 60. So these problems are pretty simple, less complicated than what we were doing with the fraction coefficients. We're going to multiply. 4 times 5 is 20. And I hope you paused and tried these on your own. And then 3x times 6 is 18x. And we're solving for x. So it's multiplied, so we're going to divide. Now this is the type of problem that threw some of you off in the past, because if you look at this, 18 does not go into 20 evenly, and some of you panicked a little bit when you saw this, but we can have fractional answers. So x equals 20 over 18, but I'd like you to simplify. So 2 goes into both of them, so I have 10/9. We can have fraction answers. So please pause and try this next one on your own before continuing. Alright, so I'm going to show again that I'm going to multiply the extremes. 2x times 5 is 10x. And then I'm going to multiply the means, except this time you have to make sure that you are multiplying both of the terms by 4. In other words, you have to use the distributive property. This whole expression, 3x minus 2, is multiplied by 4, not just the 3x. Most common mistake made with this type of problem. So I'm going to continue. 10 equals, and use the distributive property. 4 times 3x is 12x. 4 times 2 is 8. And then I'm going to solve the equation. Here is my variable term. It says minus 8. So I'm going to add 8 to both sides. So now I have 12x equals 18. It's multiplied, so I'm going to divide. So I have 18/12. That looks like a fraction. Leave it as a fraction, but simplify. X equals, 2 goes into both, so 9/6. That's still not simplified. 3 goes into both, so 3/2. Or you could have noticed that 18/12, 6 goes into both, which would have given us the 3/2. So that's solving equations using proportions, and I want to just do one problem with you for writing and solving equations. We have already written equations in the last unit, so I am hoping that this will be pretty easy. Mr. LaRue is trying to earn money for a greenhouse, so he has started charging a $10 entrance fee to get into the lab, and then an additional $1.50 per minute. So what that's going to look like is $10 up front plus an additional $1.50 for every minute. We don't know how many minutes. That's what we're looking for. So that's our variable. And they paid a total of $47.50. All right, but here's the deal. For you to have this problem correct, you also have to define your variable. You have to tell me what this variable represents. So I'm going to erase all this, and I'm going to start with defining my variable. When I read the question states what we're looking for, how many minutes. So that's what my variable is. X equals, or let x is how I'd like to say it. Let x be the number of minutes. And you could even be more specific and say the number of minutes in the lab. And then you can write your equation. So we started with $10 and we added to that $1.50 for every minute that we are in the lab, which again, we don't know how many minutes, that's what we're looking for. And our total bill was $47.50. And then we can start solving for x. So we have to subtract 10. So now we have the 150x equals 3750, and divide by 1.5. And if I have not said this to you already, because you've been watching the videos instead of coming into the sessions, please know that it's really okay for you to use calculators for this. So if you calculate 3750 by 150, how many times does 150 go into 3750? Or if you calculate it like this, either way, you should come up with, 25. So here's your let statement, here's the equation, here's your how you solved it, and so you need the solution. They were in the lab 25 minutes. Do not forget the label. You could even write a whole sentence. He or she was in the lab 25 minutes. So LaRue made a lot of money.